course, it never happened. And then 10 years later, it was XML. XML databases were the hot thing of the day. It was going to take over the world. It was the end of relational. It never happened. And then after that, NoSQL came along. Not quite the demise of the technology, I would say, yet, but they brought some interesting and good ideas with them. Distributed data, this ability to use off-the-shelf hardware, cluster computing, and all of those great things. And eventually all this made its way into the cloud as well. And that's been very, very useful. Okay, we'll talk a little bit about that shortly. So in terms of agenda, it's very simple. I don't have very many slides. Most of it is code. And as I said, there is an associated GitHub repo where I've put everything. And as I said a few moments ago, I'll make a fix that will correct the small error that I made, for which I apologize. Okay, so we'll talk a little bit about the technology in terms of introduction, fintech, and then just dive straight into the demos, which will take up most of our time. Okay, so what will you learn today? We'll look at stock tick and stock sentiment data with single store. And we're going to use something, this LangChain SQL agent with single store DB. And that's actually something very useful and very interesting because if you've worked with things like vector embeddings, for example, and you know that that is very helpful in terms of being able to ask questions. But the thing is, you have to go through the process of creating these embeddings in the first place. And sometimes, not that using the SQL agent from LangChain is a kind of a second division or a plan B type of scenario, but it gives you an alternative. May not be quite as full-featured, but nevertheless, you can use it in very interesting ways, okay? And we'll try to do that a little bit today. And what I would say is a little bit later, we'll open it up for some questions. So if you've got some ideas for some queries that we can pose to the system, send them in, okay? Matt will make a note of them. Whichever ones he thinks are interesting, I will run them for you live against the system, and we'll see what kind of response we get back, okay? Both in terms of the notebook, which tends to be a bit more stable, and the speech to text as well, which, we'll see how that performs. We're going to use OpenAI's open source Whisper. I discovered this recently, and Matt mentioned David Lee, and it's courtesy of David's demo, which he did a while back. We had an internal demothon, it was called, and he produced this awesome demo using this speech to text. And I thought, well, I'd like to have a go at that. So I didn't look at his code, but built from scratch. And mine is somewhat more simplified. But the thing is that OpenAI gives you a couple of options there. You can use the entirely open source version, which is what I did, or you can use their service, the API service that they provide. And that obviously costs a little bit of money. So I opted for the open source version simply because I found that to be more stable and more reliable locally in my environment. And as a result of that, you can actually build some basic chatbot capabilities without having to do too much, work in this regard. So we'll take a look at that. All right, then. So a few words then about single store DB. So as I said before, I've been around the block. I've been and seen, been there, done that, got the T-shirt kind of thing. And so in my IT career, I've seen lots of waves of database technology. Sometimes it's come and sometimes it's gone, never to be sort of not really to be seen very much or heard very much later on. And so, round about 10 years ago, I think we started to see the emergence of these kind of real-time distributed systems. SQL-based products have started to come around as well, utilizing some of these capabilities that the NoSQL crowd have kind of had in terms of distributed computing, cluster computing, off-the-shelf hardware, and so on. And so today, despite all the arguments that have been leveled against SQL, that it's it's the kind of thing that my grandfather used to use. Well, I like my grandfather, he's a great guy. So there's nothing wrong with that. Having technology that's mature, just because it's old doesn't mean it can't do the job. And SQL has had a revival, and it's one of the top most demanded skills today in terms of programming languages. And the development of these distributed SQL database systems, of which single store is one, have clearly shown that you can take many of the ideas of distributed computing, apply them to SQL and distributed SQL, and you get great benefits from that as well. And so this is really one of the great things about the developments that we've seen in the recent past. So single StoreDB, universal storage. Okay, so it has this ability to store both OLTP and OLAP data, okay, in a single sort of storage data table type that's patented. So historically, used to be called MemSQL, focused very much on in-memory and OLTP, but the development of columnar has been added, and this gives you this ability to really handle both of these types of data. You can connect it to a wide variety of external systems as well. In the couple of years that I've been with SingleStore, so I've written articles that cover integration with Spark, for example, with Kafka, and today we are actually going to use a Kafka broker, which is currently streaming some data in to a database system, and we'll look at that momentarily. Other things, so it's available on the 3 major cloud platforms in the Western world. There we go, AWS, Google Cloud, Microsoft Azure. You can also run on-prem. If you so wish, there is a Docker version as well, which is great to try out, low cost, no cost, zero risk. You can get a license for a 4-node version as well. That can something you can install and run yourself free of charge as well. That could be a useful way for you to gain some experience and hands-on. It's not called SingleStore for for any just because we happen to do the table there, but there's also multi-model. Okay, there's many of data types that we store, relational, obviously. Let's get my arrow here. So geospatial, I've demonstrated those capabilities. We have the Lucene full text engine built in as well for full text search. It can handle key value. Okay, we do JSON. Lots of improvements in that space, and Matt will remember we've covered this quite extensively over the last couple of months, especially with the announcement of SingleStore Kai from MongoDB, for example. Time series, I'm going to look at a little bit of that today, and vectors as well. Okay, so vector support is something that the product has had for quite a long time, since 2017, I believe. It was actually a financial customer that requested this capability, and we are not the company that has just added vector support yesterday or today, as seems to be the flavor of the month. It's been there for quite some time, and we have customers using those capabilities in production environments. Okay, they are real systems that they are building. Other things quickly. So real-time decisions, AI apps, and dashboards, ad hoc queries, ML, all of these things are possible. And again, we have lots of content around this that I've personally worked on, as well as all the assets that SingleStore provides in this space. Okay, so specifically looking at machine learning then with a database system, this list is not exhaustive by any means, but just some of the technologies that I happen to have worked with over the couple of years that I've been here. And one of the things that I tried over the last couple of days was to do some sentiment analysis of financial data. And I used FinBERT, I think it was, Financial BERT, and Hugging Face to actually generate that data. But it occurred to me that there is actually a better way I could have done it, and that is through using this code engine for WASM. So previously, I've demonstrated the ability to store data and do sentiment analysis. So essentially, we're extending the capabilities of the engine by writing some UDFs and having those execute in their own environment within the database engine in a safe and protected environment. And the technology that I used was VADA, Valence-Aware Dictionary and Sentiment Reasoner. So that is something I applied to a movie data set, and it works awesome. And I think that's going to be my next kind of article, that I'm going to take those ideas and apply them to the financial example, which unfortunately on this occasion I didn't have time to do because it's a little bit of work having to set these things up repeatedly, but it's worthwhile to do this and demonstrate this as well. Okay, so OpenAI is very much the focus for us today. Okay, and so specifically in fintech then, well, this is probably quite recognizable for you. You can see here these candlestick charts in the middle there. A huge market in terms of technology, global adoption rates, they are very, very high indeed. And even consumers, people like me who don't necessarily work in this space, although I have past experience in this space, are aware of at least one fintech service. Again, I think that's the general consensus there. More broadly, then, in terms of single store and some of the customers that we have, I ought to make it clear that these are not customers that, let me just try and get my box. I think that would be better. Here we go. All of these, not necessarily all of these are working in AI. Okay, Matt, I think, is planning to get a specific customer to come and talk about their use of AI within the fintech space, and that's something that I think is planned for the near future. So that's something we'll look at, soon. So some of the things that would be relevant, things like risk analytics, real-time investment performance calculations, API platform for streaming market data, embedded finance apps, and peer-to-peer alternative payment financing, and so on. Okay, so there's kind of elements of little bits of this today. We haven't got the time, unfortunately, to cover all of these, but we'll try and get through at least some of these aspects today. Okay, and then let's just go straight to the demos. Okay, so what I'm going to use, as I said before, there is some data that I've preloaded in, which I used Finbert and Hugging Face for. I'll point that out to you. So that's something, the file for the data is already available on my GitHub repo. You don't need to do anything. It's already prepared for you. You just load it in. But like I said, I would like to try another way to do this using WebAssembly and writing some code in Rust and using something like Veda and see how much more efficient that might be over the existing approach that I used. We will take a look at the vector embeddings, okay, very briefly. That's something we've covered quite a lot in many webinars in the recent past. And then we'll also look at the open source Whisper as well, see how to apply that. We'll use some LangChain, okay, to take, say, some financial analytics documents, PDF report of some kind that might be very useful for us. You can choose your own, okay? So I haven't given a specific one, but I'm using an example today for myself. I mean, pick something for yourself when you actually want to try this out, and we'll see some of that in action. And as I said before, the SQL agent, very, very powerful in my opinion, and can provide some great capabilities, which we'll have a look at today. For a lot of the generative AI that we do in terms of the question and answering, and I ought to point out here again that we do have a ChatGPT plugin available on the OpenAI website. The plugin is free. From my understanding, that you do need to have GPT-4, I think, and for that, I think currently it's a paid service from OpenAI. So just be aware of that. We don't make any money out of that, neither do we charge anything for the privilege of that. And that was a technology that's been, again, demoed quite extensively in webinars, previous ones. And that is a great way that you could actually utilize something that someone has already built and apply it to a problem that you have. And so that could save you quite a lot of time. Again, it's, ready to roll and ready to use straight away out of the box. Generally, in terms of the approach that we take in terms of building these vector embeddings so that we can ask interesting questions, is taking some source material. The PDF file that I've got, I did exactly that, broke it down into smaller parts. Got the vector embeddings for these. Okay, so remember, these are simply the numerical representations of what the text is, semantic meaning, okay, that's associated. So for us as human beings, it's easy, yeah. But for a piece of software or a machine, it's much harder to kind of understand what is the context. What does this actually mean in relation to other things that you may be saying? Then, of course, we want to ask queries, something useful that we want to get back from the data that we have. And again, these the query itself has to be converted to a vector, and then we perform something like a k-nearest neighbor search and return the top results. Okay, and then use that as context to kind of answer it. So this is the general approach. All right, let's move on. Okay, now I'm going to stop there. That's the actual summary you can see. So let's drill down a little bit. Bear with me a moment, and I will just set up the share appropriately. So we are looking at the thing that we should look at. There we go. Okay, so let's have a look at a little bit of the data. And what I've done, okay, so I've set up a database. It's just called time series DB. Okay, and I've just said use it, all right? And then what I've done is I've set up two tables within that. One is called tick, storing the ticker data. Okay, so it's the symbol, timestamp, and then we've got open, high, low, and then price to represent the closing price, and then the volume. And also I have stock sentiment. So this is what Finbert and the Hugging Face was used for. Okay, here. And this one is got a couple of things that are similar. So we've got the symbol, obviously, and we have the date, the headline itself, okay, from which we're trying to derive what is the sentiment. And then we've got a value associated with that in terms of whether it's positive, negative, or neutral. And the URL as well, the link and the publisher, you know, who was the actual company that published this particular headline. So within the tick table, okay, I've got a pipeline set up, which is pointing to this public Kafka mem compute. This is owned by Single Store, and it's generating this stock data, and it's continuing. The feed is running. I've already enabled it. It's reading in this data into the tick table for me. Okay, and we can actually take a look at an example just over here. Okay, so if we say just select everything and show me an example. Let me just try and make this. There was a time when hovering over these using the command key would actually make this quite a bit bigger, but anyway, it doesn't matter. Here you can see an example. Okay, the symbol, the timestamp, open, high, low, price, and the volume in terms of the trade. Okay, so that's continuing to stream in, and I can take a look at how many of these are actually in there at the moment. And currently it stands at, let's see, about 23.5 million entries within that table. It picks up fairly quickly, but again, remember, these are random, and we can take a look at these in just a moment, some of these. Okay, and let me just switch across to here in terms of notebooks. So very straightforward in terms of doing standard kind of operations that we might require in the, in the financial sort of applications. Things like average aggregate, for example. Here, just fairly well-structured SQL. And as you can see, it's returning the results. I mean, here I'm just returning 5 rows as an example to give me the average price for these stock symbols. We can do things like time bucketing, okay, first, last, and then just normalizing to the nearest bucket time here. This is, I think, again, something that was requested by a financial customer. Here I've got it over 5 days. In reality, because the data is fairly short, I'm only doing it from about an hour or two ago. The results are not particularly interesting, although I could try and run this again and see if we get anything better. No, currently it's just showing me 1 row for this. Needs a bit more time, I think, to keep going for that. That's fine. Candlestick charts, we saw that in one of the slides a few moments ago. Here, again, it's simply because of the time. I've narrowed this down to say, okay, just do it for me for one day. And there you can see it's published as a table. Equally, we can create some nice graphics of that using a bit of plotting software. So here you can see the green, I think, is upward movement, and the red is kind of downward movement. So that, again, is very, very straightforward. Smoothing using a sort of windowed aggregate. Here, I'm doing it again for the Apple AAPL. So over time, and then things like as of as well, show me everything and just limit it to one for a particular date here where the timestamp is less than this particular value, which happens to be today, 13th September 2023, before midnight. And there's currently, I think, one row showing there, which is exactly what we want. The key thing here is that you can see that these queries are fairly well structured. They require a little bit of knowledge of SQL, obviously, and then a little bit of knowledge in terms of the domain and the problem that you're trying to solve and how you go about that. Familiarity with the schema as well. So that's fine up to a point. Sentiment data, we've shown and seen a few moments ago. I mentioned that to you in terms of the structure. So here are just some rows that I pulled back from this, just showing me the key headlines and then showing me the sentiment, the positive, negative, neutral, and the actual symbol. Now, this data is limited to 300 rows simply because I didn't have time to run Finbert and Hugging Face across the entire, I think it's over 1 million rows. Resources exhausted in my environment. That's partly why I'm interested to try the WebAssembly approach to see if it produces better results. But all of the sentiment there is related to this symbol A, which is 300 rows of that. Well, it's fine for illustrative purposes. That's okay. That works fine. Okay, so very, very straightforward there. Now, the other thing then, in terms of what else could we do? So currently, we've got the ability to query our data in a very structured way. We also have the ability to look at sentiment data, for example, and then because we have the same symbol across both the tables, we can join across the same symbol, retrieve some sentiment that could help us in terms of deciding upon our strategy, buy, sell, whatever. And show us the sort of prospects, if you like. So that is something, in terms of, again, having some knowledge about the schema, understanding the domain, understanding what sort of information we want to look for is very straightforward. Other things that we could add to this mix is simply through LangChain, taking, say, a report. In this particular case, I picked something from the Northern Ireland FinTech. This was something that was published a few years ago. So this provides an assessment of the financial, markets and the application of that, the leading companies within that space in Northern Ireland from a few years ago. The reason I picked this particular document is that it's reasonably small. It's only, I think, 11 pages of PDF. You can do this obviously for much larger documents as well. But the thing is, what this does is this gives you the ability to take this data, have it chunked up, stored in the database system, which is done here, and through the LangChain integration that SingleStoreDB has here, we can split the document up, create the embeddings, and then once it gets to a point where we have everything stored, we can start to ask kind of interesting questions. And so here is the kind of the format of the content. I'm not looking at everything here. So we're looking at a little bit in terms of I think the first 30 characters of this field, simply to contain it. Otherwise, it would be just too much to demonstrate. And there's the embedding. Notice there that I didn't have to write any SQL to do this. This is managed for me by LangChain. So the integration frees me up from having to worry about the storage. It goes away, chunks up the document for me according to my requirements, generates the embeddings for me through calls to OpenAI, stores them in a table of my choosing, and then this is the internal kind of representation of that at the moment. Equally, we could get these values back if we really wanted to look at the numbers. Let me just see if this thing works here. Is that going to work? no, unfortunately, the command and hover is not giving me the full text there. There's the internal representation. Again, that's fine. I mean, we don't really need to see that, but just to show you that this is how it's actually stored. The value itself that's gone behind that, you remember that from the slide that we showed just a few moments ago. Once that's done, again, that helps us, because what we can do then is, with these kind of documents and this information that we've stored in our database system, we can ask interesting questions. Like, here's one that I formulated, what are the best investment opportunities in blockchain, for example? Okay. And this then goes away. It gives me a summary, finding the most relevant parts of that document that I've stored within my database system, pulls out the appropriate sections here, and then I can see some references here to Pricewaterhouse, for example, and I can see some references to Vox Financial Partners here as well, and Rakuten Blockchain Lab. So these must be the key players as far as blockchain is concerned in Northern Ireland, based upon this particular report. And then this information, then I can pass again to ChatGPT down here using OpenAI and ask it for its assessment. What do you think in terms of the investment opportunities? It analyzes that, gives me this result back to say, well, look, here's what I think based upon the information that you've sent me. What is the impact? What is, who are the key players? And it summarizes for me in a nice way. So very useful to take information that perhaps we could obtain through third parties, analysis of the fintech space, store that data in our database system, use that as a means to assess the market, look at the key players, look for opportunities in terms of investment potential, have ChatGPT here assisting us in that. It does the legwork for us. It does the hard work, the summarization, for example, and the key elements, because we've provided it with the relevant information, although that may not necessarily have been part of its original data set. Very, very useful there. Finally, then, the SQL agent aspect of this. This is really just a couple of lines of code, but extremely powerful, again, in terms of the capability. So here, for example, I can run this agent. I have a query. I can say, from the tick table, which stock symbol saw the least volatility in share trading in the data set. And straight away, it can give me an answer back here. So whilst I could write this in SQL code, here, what I can do is I can interrogate the system through natural language, through English. It will run this against the query, against the data. My query will return a result. And in this particular case, because we are doing it against the tick table, not the sentiment table, notice that I was quite particular in specifying what table that I wanted to access here. So again, I do need to have a little bit of domain knowledge in terms of asking the question. But once I do that, it can give me a result back. And this doesn't use any embeddings. So you've seen a couple of different ways that we can store the information inside the database system. Some scenarios where vectors may be particularly useful. Some scenarios here where, for example, we can directly access using an agent to be able to interrogate and query the database system. And here, I've got something that I can run. Matt, anyone recommended an interesting query that you've seen? We can try it.
That's a great question. We can pose that to the crowd right now.
All right, we can come back to this. No problem. So, like I said, I mean, it does require a little bit of thought in terms of asking the question in English, because essentially the entire database is available to this agent. We could narrow it down, okay? But here, for example, I've taken the opportunity to create multiple tables within the same database system. But in order to ensure that it is asking the right part of that data and the right table, I've qualified that specifically here by saying use the tick table. And then I'm saying, look, here's tell me which stock symbol saw the least volatility. and then it comes back and says, okay, it happens to be FTR in this case. Doesn't give me a price or anything else. I could qualify that. Again, ask it for some more details, but there we go. Anything
Hey,
popped up there,
Akmal.
Yeah.
Yeah, we do have, this is kind of a fun one. I'm not sure if this is a question I'd love to know if we were dealing with
Okay.
real data. But VJ says, what will be the price of NVIDIA by the end of 2023?
Okay, well, we'll try. I mean, this is kind of futurism, all right? Let's find out what it does, all right? Let's run this, okay? So I'll type that in. What would be the price? And disclaimer, all right? Single Star is not responsible. I am not responsible for your financial decisions. What would be the price of NVIDIA? What was it, at the end of 2023?
At the end of 2023, yep. There's a couple more in here too, but yeah, go ahead.
2023, question mark. Let's see what it makes of that. See if we get back anything, all right? Let's test this out. We might have, probably should have added something like from the tick table, okay? Just to qualify. It says, I don't know. There you go. So it's smart enough to know that you're asking it something that's in the future. It can only base its decisions on what it sees, right? That's the key thing. All right, so we could qualify that instead. Let's say, let's ask it the question, what is the best price of NVIDIA? NVIDIA, if I can spell, right now.
There's no I at the front of NVIDIA, by the way. It's just
RIGHT. Oh, sorry. Yes, you're absolutely right. I should know that. There we go. NVIDIA.
There you go.
Maybe if we tried it again with the previous question, we might. I know. I suspect it's probably going to say the same. All right, let's try this again. Okay, well, it's definitely thinking about it. Right, there we go. The best price right now is 107.26. There you go. So that, remember, this is fictitious data, okay? Please don't use this for your investment decisions. I must emphasize that over and over again, right? I don't want to be responsible for any problems there. All right, that's great. So you've seen a couple of examples. Remember, this code, this notebook, all of the assets will be available to you, and I will make that fix. Now, what was the problem that occurred that caused me a bit of frustration just before I, we started the webinar? Well, the problem was this, that I unfortunately added this particular table where I'm storing the PDF document into the same database where I have the tick and sentiment tables. And because there is some meta information being stored in a JSON format in that particular column of that table. So it's storing the chunked up text from the PDF document, it's storing the embeddings, and there is some meta information as well, which I totally forgot about. So unfortunately, when you start to query it using the SQL agent, because you provide it with the database name, it looks at all of the schema. It wants to figure out what it is you're asking it, and therefore it uses all the information available to it, and it falls down because it doesn't understand the JSON. Now, one way that you can do something very interesting is back here. Let me just see if we can demonstrate this. Okay, so one of the things that within this SQL agent is this ability to actually see what is the process that it's using to evaluate it. So the verbose mode is currently set to false. Let me change that to true, okay? And I'll just rerun this, okay? So that, and for those of you, I mean, we are using temperature equals 0 to keep it as deterministic as possible. So that's done now, okay? And now if I run this sample query that I had from earlier, from the tick table, which stock symbol saw the least volatility in share trading in the data set, if I now execute this, let me just see this, bear with me. Okay, so there we go. It shows you its thinking process. How is it actually going to evaluate that query? What are the steps it's taking? What is it interrogating? And then how is it figuring out? You can see its kind of workflow, if you like. And therefore, that's kind of useful to understand how is it actually working, all right? That's pretty useful stuff. So that's great. All right, now, we've got a couple more minutes, okay? So I did one last thing, as Steve Jobs used to say, or one more thing, I think was his catchphrase. And by the way, I saw the Apple event that was beamed last night, and yes, some interesting offerings there in terms of the new iPhone and the Apple Watch and so on. But so using OpenAI's Whisper. So if we just take a look here, okay, so to take this a step further then, all right, can we do something a bit more useful with this in terms of automating some of this and having this kind of speech-to-text recognition? So let me just try this. And David is, I think, with us. And so he built this originally. My version is quite simplified, but let's try it, okay? Don't worry about these slight warning messages. It's simply because of the, let me just move this out of the way, okay? So this is the first iteration, okay, the audio recorder. Okay, Matt, any questions that we can try? Has somebody got I've got a few canned ones if we want.
Yeah, you're talking about questions to the stocks.
Yeah.
So there was a cool
one.
one. I mean, I don't know if this will appear when you're using mock data, but there was a cool question that was, can you identify any stocks that have an inverse correlation to Apple?
Wow. Okay, I'll try. Okay. Can you identify any stocks that have an inverse correlation to AAPL?
You got it.
Right. Okay. Well, it says here the stocks that have an inverse correlation to AAPL are AAAAAAAA. Warning messages. Okay, that's simply it's my environment here. Let me try just move this up so that Zoom is blocking my view here. So let's go. Let's take this a step further. All right. So this is phase 2. Let's try that. There we go. Takes a bit of time to. I struggle with this a bit because you've got to think about queues and multi-threading and non-blocking and all sorts of stuff. All right, Matt, I got any questions? Anything interesting? Any other? I like I said, I got some canned ones we can try if you haven't got anything there.
Yeah, there is. Well, here's a question: can you do any correlation between sentiment and price action? But I don't know if do you have the data to be able to answer
you
that?
could do. Yes, you could do, but you just need to, I think, phrase it carefully. Just phrase it appropriately so that there's enough information for it to figure out what you're asking for. But I mean, maybe that's something that people can try by themselves. Let me try a couple of my canned ones, okay? So I'll ask a simple question there. All right. So how many rows are in the tick table?
Hey, by the way, the screen seems to have frozen, like we're on one screen, and maybe you're talking about something that's not showing on screen. I'm not sure if you can correct that or not.
Oh, thank you very much, Eric. Let me just make sure we have something showing here. And can you see that one okay?
Yes.
Okay, great. So there we are. So how many rows are in the tick table? There are 23,600,000. As you can see, it's gone up a little bit more, a couple of 100,000 more since we last queried that. That's great. All right. And we got time, I think, for one last iteration. This is the third and final one. Like I said, all the code is available. Okay, you're welcome to take this and run with it. And oh, sorry, I'm just trying to be too clever here. All right. So there's one interesting thing. All right. So again, I'll do a canned one. Okay. I think there's some great questions that people have got, but I would suspect we need to just phrase them a little bit more carefully. Let's have a look. Let me ask this question then. All right. So what's the best performing stock in the tick table?
The best performing stock in the tick table is PCLN.
PCLN. Okay. All right. Let me try another one.
Very cool.
What's the worst performing stock in the tick table?
The worst performing stock in the tick table is FTR with a price of 3.28.
Okay. What is the earliest and latest timestamp in the tick table?
The earliest timestamp in the tick table is 2018-11-020000, and the latest timestamp is 2020-06-010000.
Okay. Here's the last one then. Who was the first man on the moon?
Neil Armstrong was the first man on the moon.
There you go. It's smart enough even to answer that. Okay. So thank you very much. Okay. So there we go. I think let me just switch and we'll just wrap up there. Bear with me one moment. Too many windows open on my desktop, and I just need to create a new share, go back to Google Chrome. Hopefully you can see that, and let's get back to the slide deck. So just to summarize then what we have seen. So hopefully you've seen the ease with the stock data. Dead simple to manage that. Stock sentiment we can do as well. It's just a question of how you go about creating that sentiment. So like I said, you can use things like Finbert, Hugging Face. I am going to investigate WebAssembly and see how that will work with Veda, Valence Aware Dictionary and Sentiment Reasoner. It should be a lot easier in my opinion, but I'm going to test that thesis by actually doing it and then writing an article on it. LangChain SQL agent, very powerful, gives you a lot of flexibility and a lot of control. You can see its thinking process. You can utilize it without having to do embeddings. I mean, that's what I was using for that speech synthesis just now and the Whisper. I was not using embeddings. It's purely interrogating it based upon the English and then going away and discovering the schema, if you like, and the information there and being able to pull that back. The open source Whisper, it's awesome. There is a GitHub repo for that. Have a read of that. There's many languages that are really well supported. Spanish, I think, is surprisingly the best one, in my opinion. Okay, I mean, I would have thought that because it's kind of English, trained on English, which I think is one of the specific things that you can pull out of it. And I'm using the English data set, which is kind of base. It's one of the smallest ones, simply to fit in the environment that I'm currently running. But loads of other languages are supported well, but the accuracy, I think, is less good on those. You can use OpenAI's own Whisper API if you want. I used the local install, the open source version, simply because I found it gave better results and it's more reliable because it's a local install. It doesn't have to go across the internet. I'm currently running on Wi-Fi, which tend to cause problems sometimes, and I was getting garbled results back. And I thought, no, enough. Let me just do the open source. Building a basic chatbot for questions and answers, very straightforward. Remember, we have a plugin already that allows you to do many of these capabilities. Equally, you saw there the simplicity and the ease with a little bit of Python code and some capability there that you can build something yourself, taking speech to text, having that interrogate your database system. But you do need to have, like I said, some domain knowledge, some understanding of the schema so that you can ask the correct queries. Otherwise, you're not going to get very useful information back. I think we have one more slide to show. Matt, did we not have the there we are. Real-time developer conference. And I will hand over to Matt for this.
Yeah, perfect. We are excited to announce that Single Store is sponsoring $100 off discount codes for the first 100 respondents to this offer. We've got these discounts for the upcoming Real-Time AI Developers Conference, which is in San Francisco on October 17th. It's at the Chase Center. It's a one-day conference with keynote sessions from industry leaders at Langchain, AWS, IBM, much more. Check out that link or that QR code that's on you. This was interesting to me. It's from Deborah Wall. It says she wanted to ask, act as an expert financial advisor and recommend 3 stocks that demonstrate the highest growth with medium risk range. And I'm wondering if that's possible in an application like this, or if it's more, more transactional or more basic, like what's the highest stock price, or is it capable of designing or handling that more complex of a question? You're on mute, by the way.
Thank you, Matt. Have you got that as text there from Deborah?
Yeah. Let me.
All right.
Yeah, let me
send it to me as text, and let's put it into the system and see what it makes of it. All right.
Yeah, I'll put it in a chat to you right now.
All right. Okay.
You see that in the Zoom chat?
Okay, there we go. I got it. Yeah, I see it. Let's try it and see what it comes up with. I suspect we won't get anything useful, but remember, we are putting information in and we are trying to get information out, and it's only as good as what it knows. There we go. In this case, it says the stocks with the highest growth and medium range risk are A, and A. And now I wonder if that's because of the sentiment table. So it's queried that as well as part of this, because I wasn't specific enough here. But if I say to it instead, why don't you just look at the tick table and then what's your assessment based on that? So we could ask the same question and then say, using the tick table, let's try that and see what it makes of that. See if we get anything better. All right, so it's thinking about it, and there we go. Figuring something out. All right, taking a bit of time. It's definitely thought there. All right, let's have a look. Okay, so I have a feeling this is where it's deep thought. What's the answer to life, the universe, and everything? Okay, here we go. It seems to suggest that FOXA, and FOXA. So it's recommended the same stock 3 times. But I think if you could build in more, we were kept our, the scope very simple in terms of the feed that we've got, plus the sentiment, which is very restricted. But I think if we were able to add more information, this would be far more useful in terms of being able to make recommendations for us. That is something I think we should definitely look at. But certainly it can handle the question. Whether or not it's useful, I don't know.
Good stuff. All right, and reminder, you also have Eric and David if you want to delegate, but I'll pose these questions to you. The first one is, for incorporating memory into the LLM, would I need to use Pinecone or have a cache set up for that?
You don't need Pinecone. Single store will be enough. Eric will be able to answer this much better, but we have a roadmap where we are working on some super cool features. And so the current way that we handle this, we do dot product, Euclidean, there's a whole range of other vector functions that the product has had for quite some time, customers using those, but we recognize that we need to do better, and there is additional capabilities that are coming down the road. So Eric, I think, will be better placed to answer that. But like I said, you don't need Pinecone. One product, single store will be enough.
Yeah, that's absolutely right. And so, single store, you can query doing nearest neighbor search with dot product or Euclidean distance using SQL. And it's very powerful to put in other filters on different properties or columns. It's more powerful than what you get from these specialty vector databases like Pinecone. And we are actively working on approximate nearest neighbor search with an index, which is not needed for most applications today. You don't need it. We have fast enough nearest neighbor search with our scalability and very high performance implementation of dot product, scale out, compile queries to machine code. We're working to make that even better. One thing that we're seeing with a number of customers is they like thinking of us as a place that they can have both the hot vectors that they query a lot, as well as the more sort of archival vectors that they might, not need instantaneous response time for, but they might have like 12 models that they've experimented with for one set of text, then using like 12 different AI models over a course of months, experimenting with the models to see which one is best. And you might have a set of embeddings for the same text documents from 12 different models, and maybe only one of them is hot in production. The rest they might just experiment with like once in a while. So people are using us for those sort of warm but not super hot, use cases with vectors, and they can use this for the hot stuff as well. And we're continuing to improve that.
Cool. Maybe time for one or two more before we announce the AirPods winner. The first one here, Akmal, is what is the advantage of using single store at the end of a Kafka Spark pipeline versus Cassandra?
Oh, I used to work for DataStax, so I know quite a bit about Cassandra. So I think that again, depending on what your use case is, and this is where David would be a much better person to answer that question, because he works day in and day out with customers on exactly these kind of scenarios. But what I would say is that using our connectors, the Spark connector is absolutely super simple to use, very, very powerful, gives you query pushdown as well into single store. The Kafka, as you saw, the connection I was able to set up very, very easily and very quickly. In this case, there's no password or credentials to provide. That is available as well. But the thing is that it can ingest the data in parallel at scale, and that's the performance benefits that we get. I realize that other technologies, other vendors have similar sort of offerings as well, but I think as Eric was pointing out, that often with this, single store has a wide range of capabilities, so one product can manage multiple needs. And so if you want to stream data in, and we'll be doing this next week as well for the IoT webinar, by the way, we'll be again focusing on streaming data in single store, utilizing this capability, these pipelines, and then at scale being able to make sort of intelligent queries of the system.
Awesome.
David, any thoughts on that? So just because I know you work with customers all the time.
Are you on mute, David?
Yeah, so I was answering as many questions on the side as I could.
Sorry about that.
There's more questions here than we can possibly answer on this session. But can you summarize that really quick in terms of the ask?
Yeah, essentially, what's the benefit that we have in terms of integration with Kafka and say Spark versus say something like Cassandra or DataStax?
Yeah, well, is this in terms of like storing your vectors, or
I think more generally, vector support is, as you know, pretty widespread today. I mean, who is the new vendor today that's added vector support? I mean, it's kind of like that. That's no news anymore. Everybody's doing it, but it's a question, I guess, of more widely and more broadly in terms of the problem.
Yeah, so in terms of ingesting using something like Kafka or Spark, you can certainly do that. There's a connector for Spark as well as Kafka in single store. And depending on your use case, you can stream data in, because we are distributed SQL, you could bring data in parallel using single store pipelines, which can stream the data in very efficiently. And there's a lot of knobs in single store to really maximize the throughput, but also striking the right balance between the throughput as well as your workload. And that's something that our solutions engineering team is happy to discuss in more detail about your specific use case.
Yeah, team@singlestore.com. That's how you can reach us.
Awesome.
Max, winner?
Yeah, winner, Danny Ying, who is a data architect at Apple in Cupertino. Congrats. Thank you for joining.